Chemical reactions. So chemical reactions are structured in that reactants react to make products. So it's a bit of a math statement where we have some reactant, maybe plus another reactant, but we never use an equal sign. Just know that, okay? If you use an equal sign, that's incorrect. We want to use a reaction arrow showing that they become, but are not equal to, products. And we can have multiple products as well, or we could just have one. So during a chemical reaction, chemical bonds in the reactants are broken, and new substances are always produced with new chemical bonds. The reactants are the compounds present before the reaction happens. These are what do the reacting, or what the chemist puts into a beaker. The products are the compounds produced by the reaction. It's what isn't present initially and is what is formed. The properties of the reactants and the products are different. Okay, so the chemical properties, the physical properties, so what it looks like, what it smells like, its boiling point, all of these things are different. So remember that we talked about evidence of a chemical reaction. We could see a color change. We could see a change in temperature. Either it gets warm or it gets cold. We could see the formation of a solid, which we call a precipitate in chemistry, or a gas. So we could see bubbles formed, or we have a new smell. Here we have the reaction of hydrogen gas and oxygen gas to make water. So we've gone from a change in state here. We've got gases turning into liquid. The chemical equation, we've got kind of an example here. We have methane and oxygen, and then our chemical reaction arrow. So anything before the arrow is considered a reactant. Remember, we use an arrow, not an equal sign in chemistry. So the reaction arrow shows that it produces, or they react to form. And then anything after the reaction arrow is considered a product. We can include energy in these, but energy doesn't have a chemical symbol like our other elements. So it doesn't balance, just so you would know. So we're going to convert the word equation into a chemical equation. So we substitute chemical formulas for the chemical names. The one that you might not know is methane. Methane has a chemical formula of CH4. I also know that it's a gas, so I'll add that in. We write the state as a subscript when we're printing. Then, so we've accounted for methane. We also need to write in oxygen. So oxygen has a chemical formula of O2, meaning it's diatomic. It isn't just an O, it always comes in pairs. And oxygen is also a gas. We see our reaction arrow here. So we know we need to start listing our products. Our products are carbon dioxide, so carbon dioxide, which is also a gas, and water. Now I should add that this is water vapor. So I'm going to write it as a gas. And I've also included energy just as I have up here. Note, the law of conservation of mass says that atoms are neither created nor destroyed in a chemical reaction. So the atoms in the above reaction, as in all chemical reactions, change partners and are like old partners are changed into new substances. So in this case, we have carbon bonded with hydrogens, and it switches. It becomes carbon bonded with oxygens. The hydrogens were initially bonded with carbon, and the hydrogens are now bonded with some oxygens. So everybody switched. Nothing is the exact same on both the reactants and the product side. I don't have oxygen just by itself. It's now part of compounds. This also says that the same number of elements have to exist on both sides. So We have a carbon as an element in our reactants. We also have hydrogen as an element in our reaction, and we also have oxygen in our reactants. In our products, we have carbon, we have oxygen, and we have hydrogen. So we still have the exact same elements on both sides. Now, beyond the scope of this class, what we talk about in grade 10 is how to balance. Okay, a balanced chemical reaction means there are the same number of atoms of carbon, hydrogen, and oxygen in both the reactants and products. Because if I have 5 carbons in my reactants and only 3 in my products, that isn't conservation of mass. They've disappeared. So we want to conserve mass. To do this, I'll just go through it. Again, this is not something I would quiz you on. We have 1 carbon in our reactants and currently 1 carbon in our products. So those are balanced. I currently have 4 hydrogens in my reactants and only 2 in my products. So to make sure that I have the same number of reactants and products for a number of atoms of hydrogen, I would add a 2 in front here. I still have 4 hydrogens in my reactants, but now I have 2 water molecules. And if I have 2 water molecules, that means that I have a total of 4 hydrogens. So hydrogen is now balanced. Now, I can see that I have 2 oxygens in my reactants. And as in my products, I have 2 here, and then I have 2 water molecules, which tells me that I have 2 oxygens. So 2 oxygens from my waters and 2 oxygens from my carbon dioxide gives me a total of 4 oxygen molecules in my products. To make sure that I have 4 oxygen molecules in my reactants, I need to add a 2 here. Having 2 O2s gives me 4 oxygens. Because all of the numbers for each atom are the same, we can say that this is a balanced chemical reaction. Again, what you need to be able to do in Science 9 is simply write the formulas given the word equation, or maybe vice versa. I do not expect you to add in these numbers. However, if that's something you're comfortable doing, I think it's always good practice to take a look ahead at what's coming next. Breaking chemical bonds. So when we break chemical bonds, energy is added to our equation, or it is required to break bonds. If it wasn't required, everything would just start spontaneously falling apart and releasing energy. Energy is released when bonds are, this should say formed. Okay. So, a chemical change which releases energy is called exothermic. The idea to remember this is energy exits. A chemical change which absorbs energy is called endothermic. Energy enters. So, when energy is added or required to break bonds, we could say that this is endothermic. If energy is released when bonds are formed, we could say that that is exothermic. All chemical reactions involve changes in energy. Energy is either produced or absorbed during a chemical equation. So, exothermic reactions, again, are chemical reactions that give off energy. So the hints that it's exothermic from words or what by observations is that steam is produced or our surroundings get hot. So an example is a combustion reaction. So I have this reaction here, and it is in its chemical formulas, and we're going to write it out with its chemical names. So C8H18 is octane. That's one you might not have known. Octane plus O2, which is oxygen, makes CO2, which is carbon dioxide, H2O, which is water, and I know that this is a vapor when things are burning because it's so hot that water evaporates. And energy. So we could say energy or heat. My other example here, we're going to change our word equation into a chemical equation. Glucose has a formula of C6H12O6 plus oxygen is O2, makes water H2O, and carbon dioxide CO2. It also makes energy or heat. If you'd like, you can go in and add states. Glucose is sugar. Sugar is a solid. Oxygen's a gas. Water is always a vapor in a fire. And CO2 is a gas. Chemical reactions that absorb energy are called endothermic reactions. Hints to the fact that it could be endothermic is that our beaker or surroundings get cold or frost develops. Examples of an endothermic reaction are corrosion. Iron and oxygen plus energy make iron 2 oxide. Iron is Fe, oxygen is O2, and I know that iron is a solid and oxygen is a gas. Iron 2 oxide. Remember, the 2 tells me that we're using iron 2 plus. Oxygen is a 2 minus. I need 1 iron and 1 oxygen to balance their charges to neutral. I know that rust is a solid. So iron 2 oxide is rust. Electrolysis. Water and energy. Energy this time is actually electricity. So it doesn't just have to be heat. Make oxygen and hydrogen. So water is H2O, and this one's a liquid. React with our electricity here to produce oxygen and hydrogen. These are both 2s from our periodic table. I know this because of something called P.S. Brinkelhoff, if you've never heard of this. So P.S. Brinkelhoff says that all of the Brinkelhoff elements like bromine, iodine, nickel, chlorine, hydrogen, oxygen, and fluorine come in pairs when they're by themselves. If I'm talking about chlorine, I'm talking about Cl2. If I'm talking about fluorine, it's F2. P and S, so phosphorus and sulfur, are a little bit different. Phosphorus is a 4 and S is an 8. So if you ever see these, don't be alarmed. These are just these elements in their natural state. Okay, the last endothermic reaction, cooking. Baking soda and energy, so heat, and the formula for baking soda is here, NaHCO3. These make carbon dioxide, so CO2 as a gas, and water as a gas, and sodium carbonate. These two, specifically CO2, is the reason that our baking rises. Okay, you get bubbles in your cake, which makes the batter rise a little bit, makes it a nice fluffy cake. The practice, make sure you take a look at the learning guide for topic 7, chemical reactions.